Thanks for the amazing talk, Sarah. That's I'm blown away by how much we know about Titan to begin with, but also just how fascinating this moon is. And I really am excited to see what your group will find out in the future.
Me too. I
But
wish it
let's
was
begin.
happening faster.
Yeah, I agree with you there. So let's begin with talking about how, or Titan itself. How did Titan actually form? Um, and does this help us answer if there is life? And that question comes from Keziah.
Yeah, that's a really good question. So, if you know anything about how we think the planets formed, so originally there was a disk of gas and dust, and it was spinning around what eventually became the sun. And gravity helped pull these little blobs that kind of appeared together, and each of those blobs eventually turned into planets. We think the same thing happened around the giant planets. So instead of having the sun in the middle, like I just described, we had the giant planets, Saturn, Jupiter, Uranus, Neptune, inside of these disks of gas and dust that were spinning. And some of the little blobs, because of gravity, kind of coalesced and got bigger and bigger and built these big moons. So we think that's how Titan formed. And that does help us understand things about Titan, because we think we know some things about what the chemistry was in that area. So we think we know what the kind of starting materials were when we built Titan, and that's really, really helpful for us in terms of figuring out what the surface is made out of, what the atmosphere is made out of, what we can expect for the inside of Titan. The insides of planets are really, really hard to study because we can't see them. And so one of the ways that we study the insides of planets is by making guesses about what they're made out of based on the things that we know about how they formed. And so understanding how it formed is really important.
Yeah, that's very interesting. Do we know anything about the core of Titan, or is that a mystery at the moment?
So the best way to study the insides of planets, there's a couple of good ways to study the insides of planets. The two best ways are with seismometers. So you have seismometers on the surface of a planet, you have a bunch of earthquakes, you measure how long the signals take to get to all the different places, and that tells you a lot about the inside. So that's how we know so much about the inside of the Earth. The other way that we like to study the insides of planets is by gravity. And the best way to do that is with our spacecraft. And so we like to get our spacecraft really close to all of our planets, because the way that the planets and the moons tug on the spacecraft tells us what the inside is made out of. The problem with Titan is that we haven't sent a seismometer to the surface yet. We're going to with Dragonfly, but we haven't done it yet. And because Titan had this big, thick atmosphere, we couldn't get Cassini very close to Titan. And so we couldn't get a lot of gravity information by flying by. So we don't know a lot about the inside of Titan. And that's one of the big questions that we have for Dragonfly. But we do think that just like Europa and Enceladus and some of the other icy moons in the solar system, that Titan has an ocean deep beneath its water ice crust. But that's about all we know. We haven't been able to figure out a lot about the inside structure of Titan yet. That's a big outstanding question that we have.
Yeah, that's be interesting to see what the insides are made out of one day. We've also had a lot of interest, of course, in the prospect of there being life on Titan.
Yeah.
Some questions from Michelle are, what kind of life could be possible on Titan? And would this life look anything similar to what we have on the Earth, like, say, the microbes, fish, or dogs, or cats?
Yeah, so I see another question too that's relevant to this issue. So someone asked what the temperature is, and I always forget how to do the conversion. So Titan is 94 Kelvin, which is not a unit that most of us think about very often, but I always just tend to tell people that it's so cold, you personally can't imagine how cold that is because it's so cold. And so the reason why that's important to the question that you just asked is that life on Titan would have to be very different than life on Earth. Life on Earth is based on liquid water. It's very important. It's too cold on Titan for liquid water. And so life on Titan would have to use completely different chemistry because it's so cold. And so, one of the features of life that's kind of helpful is things are bendy. And it's hard to make things be bendy when they're that cold. And so there's a lot of reasons to think that if there is life on Titan, it would have to be very, very different than life on Earth, both because it would have to use a different liquid, it would have to use methane instead of water, but also because even just the molecules that it uses would have to be different because of the temperature being so cold.
Yeah, so the conversion for that temperature is minus 180 degrees Celsius.
Thank you. I knew someone would answer.
Absolutely freezing. I wouldn't last very long in that temperature, that's for sure.
Yeah, most of us wouldn't, as it turns out. Dragonfly will be perfectly content to be that temperature. In fact, we take advantage of that cold temperature for a lot of reasons, so it's good for us. So
with all of the interest in Titan and the incredible idea to actually fly around Titan with the Dragonfly drone, has the Dragonfly actually been built yet? And if not, how long do you think it will take to build? And that question comes from Nadira.
That's a good question. I'm gonna do the dangerous thing of stopping slides mid talk to see if I can share one other thing that I had pulled up and then has now disappeared. But I believe in us that we can do it. So hold on. What we don't need is a million different zooms though. Can you see this Dragonfly slide now? Or this, okay. Oh, but now it's not working. There, come on. So this is a flight demo that was done a couple of years ago. This is about a half scale of what it will look like in a while. So Dragonfly has not been built. Our current launch date is 2027, probably January, so that's about 6 years from now, a little over 6 years from now. We don't have any flight hardware yet. We haven't started doing what people call cutting metal. We're still designing things, not quite on a paper napkin anymore. We've surpassed that stage of NASA mission development, but we haven't actually started building it yet. We have to go through a lot of different design phases for NASA missions. And so what happens is we'll come up with a design, we'll get a whole bunch of people together in a room, they'll review that design. If everybody says that's cool, let's do it, we'll finalize the design, and then we go back and double check with everybody one more time. And so there's a lot of checking in the process to make sure that we haven't missed something, that there isn't something that's going to go wrong. And then once we pass that final review, then we'll actually start building things. And that final review is still a couple years out. So we won't start building any flight hardware or the spacecraft itself for at least a couple more years, but we are already building things to test. And so there will be lots of testing of different pieces, of the actual, the rotors and those different things long before we actually build the things that we will send to Titan.
So the Dragonfly itself seems perhaps more complicated than your average rover. And there's been a few questions on like how this all actually works. Tom asks, how is the Dragonfly powered? And Barry asks, how is it going to think for itself and pick places to land?
Those are both excellent questions. I'm very distracted by the fact that this thing didn't work correctly, but now I can't figure out how to make it stop. I'm gonna stop sharing my screen. There we go. So those were good questions. Okay, so the first question was, how is Dragonfly powered? Dragonfly is powered by something called an RTG, which is a radioisotope thermonuclear generator. Which is a fancy way of saying that we use plutonium, not the kind that you would use in some kind of like bomb or something, but just normal boring plutonium. It generates excess heat, and we use the heat that comes from it to power Dragonfly. This is the same type of thing that the Mars rover Curiosity uses. Cassini used it, New Horizons used it, the Voyager spacecraft used it. So whenever we go far away from the sun, this is how we power our spacecraft, because it's hard to get enough sunlight to use solar panels. That was the first question. The other question was, how does Dragonfly think? So this is scary. So Dragonfly is going to be doing something called terrain relative navigation, which is a really, really fancy way of saying Dragonfly is going to take a whole bunch of pictures, and that's how it's going to figure out what to do. The first flight will be the scariest because we do not have good maps of Titan. And so we can't just tell it, go fly there, it'll be fine, because we don't know if it's going to be fine or not. But after the first flight, we're doing something called leapfrogging. And so every time we fly, we're going to fly further than we actually need to go. And we're doing that to scout out the areas that we're going to fly later on. And so Dragonfly will take lots of pictures, make new maps, and then it will fly back to somewhere we've already told it is safe. It will land there, it will do its science. Meanwhile, part of the team will already be figuring out where to tell it to go next. But the whole time that it's flying, it's on its own. The one-way light time to Titan is about an hour. And so if something happens, we can't tell it what to do because we'll be too late. And so it has to carry on its computer on board all of the decision-making software to say, whoops, it's too windy, it's starting to rain, something else has gone wrong. And it has a couple of different ways in which it can decide to stop. It can kind of slowly decide to stop, as if like, seems like it might be getting ready to storm, we should probably stop, like, let's scout, you know, X distance away from us and pick the best spot to land. That's one way. Another way is, oh no, everything has gone horribly wrong, we have to land right now. And it will do its best to land right now, wherever it may be. And so for us, that's probably the scariest thing, is that the most challenging moments of the mission, we won't be able to help. But we're really used to that in planetary exploration. It's the same thing with the Mars rovers. The Mars rovers get told what to do on a given day, and they go do it. And the humans on Earth we're not able to stop it. We're not able to help it. It does the things it was told to do that day, and then it turns around and reports back to Earth. And it'll be the same way for Dragonfly, just a little more gravity involved with the possibility of crashing, it'll be fine. It's fine.
Yeah, it would certainly be an awesome achievement when it works. So with all of these challenges, you're using quadcopter blades to fly around. Is there a reason that you don't use rockets? Lydia asks, if you were to use rockets on Titan, would it explode since there's so much methane in the air?
I always want to know why people are so excited about blowing up Titan, because I get asked this question every time I talk to the public. And I did see someone in the question and answer earlier had asked if there was very much oxygen on Titan. There's very, 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 very little oxygen on Titan. And so if you tried to light a match on Titan, nothing exciting would happen. So as much as some of you might want to blow Titan up, it's not going to happen. I'm sorry. Rockets are not gentle, and quadcopters are. And so using the quadcopter blades gives us a lot more precision. And we can do lots of different kinds of flying with a quadcopter, which is different from, say, an airplane. So we can fly fast, we can go up and down in altitude pretty quickly, or we can hover. And actually some of our experiments that we're excited about trying rely on us hovering. And so we actually use the rotors of the quadcopter like a wind tunnel to try to understand how the sand moves on Titan by generating our own wind. And so the quadcopter is actually perfect for all of these things because it gives us so many different options for how we can use the spacecraft. And also sometimes we might not fly that far. It might be that we land somewhere and someone on the science team is like, oh, I want to look at that thing that's just right over there. Can we just, and so we can hop. We can just kind of go up in the air and jump over here and land again. And so we get a really lot of flexibility from flying this way. People looked at flying all different kinds of ways on Titan, with airplanes, with balloons, with quadcopters. with all of these other different options. And by far, the quadcopter is the best option.
Yeah, it certainly does seem to have an awful lot of advantages. But let's move from the future of space exploration around Saturn to the not too distant past, to the crash of Cassini. So a few people were quite interested in that. Brian and Lewis asked, why and how did we crash into Cassini?
Yeah.
Or crash
so,
Cassini? So.
Yeah, it's okay. I knew what you meant. So when Cassini was designed and developed and everything, it was never designed with the idea that it would go somewhere that has liquid water. So when we fly spacecraft different places in the solar system, part of our rules are to protect that place from us. So to make sure that we don't send any earth germs or microbes or whatever to that place. But to also, if we were to bring samples back, like OSIRIS-REx is doing, to protect us from space. And so we don't want to contaminate the places that we go. So we're very, very careful about that. So every time we fly a spacecraft somewhere, there are rules about how clean it has to be when it leaves Earth. Cassini was not designed clean enough to have it land on a place that has water. So Enceladus, Titan with its water ice, Cassini was not allowed to land on those places or to crash into those places. That was one of the rules from the very beginning. And so, however it was that the Cassini spacecraft ended, we had to make sure that it wasn't going to crash into one of Saturn's moons. And when they looked at all of the different options for what to do, the option that was decided was to crash it into Saturn and burn it up, which protected the moons. But it also let us do something that we had never ever done before, which was to actually directly sample Saturn. And so while Cassini was burning up in Saturn's atmosphere, it was ingesting Saturn's atmosphere into its mass spectrometer to figure out what Saturn's atmosphere is made out of. It was pointing its magnetometer at Earth as the best it could to figure out what Saturn's magnetic field does. And it was trying to keep its antenna pointed directly at the Deep Space Network on Earth to send all of its data back. And so we found out all kinds of really exciting things about Saturn from burning Cassini up in Saturn's atmosphere. And for me, one of the most exciting things was when I talked about all of those Legos that build up and make all those cool molecules in Titan's atmosphere. It turns out that there's a lot of Lego things building stuff in Saturn's atmosphere too. And so there's a lot of really interesting chemistry that's also happening in Saturn's atmosphere that we're really excited about. And we got to find that out by burning Cassini up in its atmosphere.
It's certainly a spectacular way to end a really spectacular missions. I'm sure if the young stars haven't seen images from Cassini, they definitely should go and look at them.
Yes,
They're
definitely.
absolutely amazing.
I highly recommend that.
And those of you who are in Canberra, part of the Deep Space Network is actually based in Canberra. And I think they received some of the last signals from Cassini. And
I was trying to remember which, I was just trying to remember which DSN station it was. And I don't remember if it was Canberra or not. They're the best.
I may have lied there.
I'm not saying this just because it's y'all, but they're by far the best DSN station, if only because their Twitter account is amazing. So I like them the best. But I can't remember who it was, actually. Which is sad because I was there for the end of mission and I still can't think of who it was. Yeah, but it was pretty cool.
So we've got an awful lot of questions from all of the people watching us today, but unfortunately we don't have all the time in the world to go over them. So we'll keep those questions stored away with us for now, and maybe we'll try and answer those in future things. But for now, I'm going to hand over to Sophia to ask the last questions.
Yes, so thank you so much, Sarah. But before we wrap up, I would like to ask you, have you ever wanted to be an astronaut? And secondly, what made you interested in astronomy?
Which question should I answer first? You used wanted in the past tense for astronaut. This isn't quite how I would describe it. But yeah, I have, since I was probably the age of a lot of the folks here, wanted to be an astronaut. I have applied to NASA's astronaut program 3 times. The first time I actually got pretty far in the process. The second time I didn't get very far. We're actually in the middle of the 3rd selection right now, and it's been slowed down by COVID. And so we haven't heard much about it yet. But yeah, I would definitely be an astronaut if someone would let me. In terms of space, I think, and I always tell people, and maybe this is true of the folks here, I guess it's afternoon for a lot of people, but I was going to say tonight, I think when you're young, like, kids love robots and dinosaurs and space. I feel like those are like the 3 things that like a lot of kids are really into, and I was like one of those kids that was like really into those things. But I had a teacher when I was, probably 13, 14, who taught me all kinds of cool stuff about planets, and I just got kind of obsessed with planets. So I think I always liked space. But it wasn't actually until I was in college that I knew you could do space as a job. So I went to college thinking I was going to study chemistry. And then when I got there, I found out you could do space as a job. And I was like, okay, well, I'm going to do space as a job then. So just, you know, for everyone's information, you can actually do space as a job.
That's awesome. Yeah, awesome. Thank you so much, Sarah.